All right, so welcome. This is Computer Science 1, specifically ECEN 194. It doesn't have a permanent number yet. That's just the number that they're using so far, but this is Computer Science 1. I'm Dr. Chris Burke, and I'll be your instructor for the semester. Just a word of information. We are broadcasting, we're live streaming on YouTube every single lecture throughout the semester. And so, the recordings are available immediately after on YouTube, along with a bunch of other videos. So if you have questions, please go ahead and raise your hand and ask. I've got baffling, so you won't be picked up, but I'll repeat the question. And as long as you aren't over here while we're broadcasting, you won't be on camera either. All right? So today we're going to give a quick course introduction, tell you how it's going to go, the format and the structure of the course, grading and stuff like that. And then we'll get started because we're dovetailing right into the lab, which occurs right after this. Yes, you got to go over to PKI. For those in the, I think, 130 section, you've got 50, it shouldn't take more than 15 minutes to walk over there. Today I will be joining you just to make sure that the TAs are all set up and ready to help you in the lab, so I'll be going over there as well. But otherwise, are you in the right class? Probably. I don't have anything to do with the registration on the UNO campus. So if you're a computer science, computer engineering major, I believe, on the UNO campus, maybe EE majors too, or just somebody that wants to get some programming experience from the School of Computing / EE department, or ECE department, excuse me, then you probably are in the right place. This is Computer Science 1. We use the C programming language as our introductory language. It's okay if you've never had any C before. It's okay if you've never had any programming language before. We start from scratch. We start with a basic Hello World program that you're going to be doing today in your lab to get set up. Okay? It's okay if you have prior experience, and it will help you along the way, but it's absolutely not necessary. Right? I am the instructor. Me. I've got a short bio in the front. I like to run. I like to read. Baseball, Cubs, NCAA baseball too, UNL, and NCAA football, but not professional football, and hockey. So I follow all that to various degrees. You can learn all about our learning assistants. They're called teaching assistants. We've got 2 grad TAs that you'll meet today over in lab and 2 undergrad TAs, and I hope to grow those more because we need more people to help out in those labs. But otherwise, for now, you can learn, you can at least see their names by going over to Getting Help and Instructor Info. They have yet to establish some office hours, or some help hours along the way, but hopefully they will at some point. Adarsha and Carl, Jacob and Trevor are your undergraduate TAs. 3 of the 4 have done this course before in the spring, so they know what's going on, and they'll really be able to help you. And the 4th one will be brought up to speed shortly. Right? Oops. So before we get into it, what is the discipline about? And I put computer science up here, but you can substitute in computer engineering. You can substitute in software engineering, any computing discipline if you want, right? We're already developing majors for data science, and maybe in the future, probably after you've graduated, a major in robotics, right? Or mechatronics or something like that. You can put all of those into the same bag here and answer, and it'll still be true here. I borrowed 2 quotes from 2 science fiction authors. One of the first one is Douglas Adams, that he says, if you really want to understand something, the best way that you can is to try to explain it to somebody else. That forces you to sort it out in your own mind and that's really the essence of programming, because with programming, you have to sort it out in such a minute detail that you have to break it down into such small parts that even a stupid machine can understand them, right? Machines only do only exactly what they're told. We're not living in AI, Star Trek fantasy, right, where the machine has a mind of its own. They do exactly what we programmed them to do, right? We are still problem solvers, right? Computers don't solve problems, we do. Computers are only good at automating solutions. Computers are very, very good at crunching large amounts of data very, very quickly. Humans are not good at that. Humans are good at solving the problem and then automating solutions once they've solved it. Only after they've solved it. The second quote is from Michael Crichton. He says, and this is in a magazine, in my experience, you assert control over a computer, you show it who's boss by making it do something unique. That means programming it. If you devote a couple of hours to programming a new machine, you'll feel better about it afterwards. This discipline is about becoming masters of the machine. Because if you're not masters of the machines will master you, right? You'll be lost in the world if you're not if you're not mastering the machines and doing and understanding them at a fundamental level, right? Again, at its core, computer science is about problem solving. Computers don't solve problems, we do. They only automate solutions. And ancillary to that is that computing, every computing discipline, is now ancillary to all other disciplines. There's no such thing as a marketing person anymore. There's a marketing person who needs those valuable software development skills, whether or not they need to be an Excel guru or they need some Python to glue some Excel sheets together or something like that. There is not a discipline out there that cannot benefit or will shortly be obsolete if you do not have the skills that are fundamental to a computing science curriculum, right? And Isaac Asimov predicted this over 60 years ago, that the world of 2014, so he was talking about 8 years ago, because it was the 50th, they asked 50 years in the future, what does it look like? We'll have few routine jobs that cannot be done better by some machine than any other human being. Mankind will therefore become largely a race of machine tenders. Schools will have to be oriented in this direction. All high school students will be taught the fundamentals of computer technology. To an extent, that's true. We'll become proficient in binary arithmetic. No, that was stupid even back then. And we'll be trained in the perfection in the use of computer languages that will have developed out of those like contemporary Fortran. Right? Look around you at all the jobs that are out there right now. Right, one of the obvious ones is truck driving, or taxi, or what's the mobile app for taxis now? Uber or Lyft or whatever they are. Right, those jobs will not be there in your lifetime. Those are already on the way out. Within your lifetime, we will have near 100% autonomous vehicles. Right. Delivery people, right? The drones will deliver everything in the future, in the near future. So think about any job that's around today that might lend itself to automation, and it probably won't be there at the end of your lifetimes, right? In fact, a lot of it could be automated right now. It's just that the cost of automating exceeds the cost of keeping things the way they are. When that's no longer true, that's when those jobs are gone, right? Now, people have pontificated that, well, computer science and programming and stuff like that, those jobs will be automated too, right? Not within your lifetimes. You don't have to worry about that, right? That's Star Trek fantasy of telling the computer exactly what we want it to do, right? Within the discipline of computer science, computer engineering, software engineering, whatever you want to call it, what is this course in particular about? It's an introduction to computer science. It's not really a programming course. It's going to seem like that because we use programming as the primary tool for delivering those ideas of problem solving, right? It's about computational thinking, algorithms, data structures, and thinking about data and thinking about process, because the entire world is a process, right? Chemical reactions are a process that can be modeled with computation. Economics are processes that can be modeled, and some people think mastered, with computation. They're not. They're wrong about that, right? Just go on. What is the subreddit? Super Stonk, right? And read all about it. People lose lots of money every day and are proud of it for some reason. Anyway, biology, engineering, all aspects of engineering. Even if you don't end up in computer science, computer engineering, or whatever your discipline is, these are going to be valuable skills that you're going to take away to every other discipline. Like if you decide to become a fine and performing arts major tomorrow, right? Guess what? Guess what the first course of fine and performing arts is on the UNL campus? Python, right? Every discipline will have and require these skills going forward, right? All right. What will you learn in this course? If you want to go ahead and take a look at these essential abstract topics here. But on the syllabus, I give you a skills outcome, basically. You'll be able to take a moderately complex problem, design what's called a top-down solution. In other words, you're going to break it down into smaller and smaller bits until each bit is so simple that you can solve it directly with one line of code, or there's this line of code that's built into the language or built into a library that you can come and just use it, right? That you can, and then you can write a program to automate solutions after you've solved that problem, right? It's organized into modules. There are 13 modules, roughly one per week. It doesn't add up to 15 because we've got an exam week. We've got breaks and stuff like that interspersed. And so there are 13 modules. Each module covers a major topic in the course itself. Just looking over here, you can see how it's organized. We've got module 1, which is this week, and it's an introduction. We get you set up, we get you going. Right? Next week, we'll start talking about, this week, and the focus of next week, will be the getting you up to speed on the basics, variables, operators, stuff like input and output. Then we'll move on to conditionals, loops, etc., and I'll let you take a look at all the rest. The way that it's organized within Canvas is you've got this blue section over here, which is all the material. As we move along in the lectures, I will go ahead and update these with links to the YouTube recordings. Or you can just follow the playlist that I've already set up. You've also got a bunch of pre-prepared tutorial videos. You can watch these before or after as a review or to better prepare yourself for lecture or for lab and hack, which we'll talk about here in a moment. We've also got recommended reading. Of course, the syllabus is just in the first week. Then we've got in the green, we've got our graded activities. Every week you will have a reading, you'll have a lab, and you'll have a hack, and we'll discuss each of those in detail. Otherwise, you also have optional readings, like some extra stuff if you want to go deeper into a topic. There's some optional viewing videos and some optional reading, as well as some resources to go along with this. That's how every single one of these is set up. Okay. Again, we have pre-prepared tutorial videos, graded readings, which are due on Monday, lectures, Tuesdays, Thursdays for this course, labs on Tuesdays, and hacks on Thursdays. Each one of those individually. The videos, the pre-prepared videos, I've got about 60 of them. That might be actually like 70 or so now. There's only about 9.5 hours of material. In other words, I keep each one of those things short. I also time index them to encourage you that if you use it as a review, you can jump to a location that you need to learn about. Like, what was the syntax of the if statement again? You can jump to that time index because it's all indexed on YouTube. You can watch them before class to better prepare yourself for it. It covers basically the same topics, but it gives a different perspective. I use different examples, and it just reinforces the material, right? You can watch it after lectures as a review of the lecture material and to see more examples, right? Every week, we're not grading the videos or anything. I have no mechanism to tell if you watch them or not. Watch them, don't watch them, right? It's your responsibility to determine what is best, or how do I learn best in this course? Which resources do I like using best? If it's the videos, great. If it's the readings, great. If it's focus on that instead, focus on something else instead. Right? Otherwise, the readings are graded. We use an online textbook called Zybooks. You read a little bit, and then they've got an interactive section where you either write some code or you answer some questions or something like that. And as you progress through the reading, and if you don't get it right, that's fine. Just try again, try again, try again, as many times as you want until it says, okay, your test passes. Great. Go on to the next section. As you work through that, your grade will automatically be updated in Canvas. Right? So if you clicked on it and said, oh, okay, this looks cool, I'll come back to it later. Then later you saw in the grade book, oh, there's a 0. Why did I get a 0? Well, you just haven't done anything yet. As you do things, it will update automatically. They're due on Mondays at midnight, Cinderella deadlines. So you don't have to read it, 5 o'clock or something like that. But you do have until midnight local time to get that done. If you have any questions, you can go ahead and take a look at the FAQ here. It also has a lot of we also have a lot of supplemental articles over here in recommended reading. Otherwise, some questions that have already come up, right? I'm at UNO. How do I get my Zybook? It's provided as your first day access. So You might have gotten an email with a code in it. Yes? No? No? Nobody got nobody got their books on the first day access of some sort? Or they had to go physically pick them up? Yeah.
I just clicked on the link in Canvas and it pulled it right up.
All right. Eventually, you'll be prompted for an access code.
I'm
Yes, no?
into my account. It says my name in the corner. I don't have access.
The first reading, yes, because the first reading is always free. But you may eventually have to enter in an access code from the bookstore. The bookstore told me that they email those out or that you pick up a physical copy of some sort. It's just a printout. Nobody's had this experience yet?
Yeah,
They sent them last week? Yeah. Okay, great. Check your email, right? Okay. UNO email, or in some cases, it might be your Huskers email. Check both. Make sure that you're checking both throughout the semester. All right? How long do readings take? You can expect them to take on average of 1 hour a week. That's average. The first ones are front-loaded. So you've got maybe 90 minutes. Maybe it'll take you 2 hours. Maybe it'll take you 3. You don't know, because you go back and you get tired of it. You leave and you come back, and you don't have to do it all at once, basically. But you can expect on average about 1 hour a week on your readings. Where do you learn more information? Here. For example, if you access the Zybooks website directly, don't do that. Go through Canvas, click on the readings in Canvas so that it associates your Zybooks with your gradebook. Otherwise, the gradebook will not know who you are. If you didn't do that and you did go to the Zybooks website, you will have to come here and email them and submit a support ticket to merge those two accounts together so that you are automatically graded. Okay? Questions on Zybooks? No? All right. Double check your emails. Tuesdays and Thursdays are right here, lecture, 12 to 1:15. Every Tuesday, every Thursday, except, of course, for the holidays. Lectures are going to be coded. I'm going to code them up in a language called Markdown that I eventually push out to GitHub. The way that what that looks like is, eventually I'll post this once we actually got notes that I can give you. You can see the old notes from all previous semesters here. But let's take a look at, fall 21. Here's the third module, conditionals. This is what it ends up looking like. I can go into code mode and type stuff. It'll also look something like this on the screen as I'm typing it. Otherwise, we type up notes, and these will all be pushed out to GitHub eventually. Right? I mention that because you will have access to the notes that I give you in class, but you should still take your own notes. Right? It has been proven by various researchers that simply just the act of taking your own notes and means that you're engaged with the material and that you're actually learning it and absorbing it a lot better than if you just sit there passively. Right? You should also limit distractions. I'm not going to police iPhones or your phones or whatever you're doing on your computers. That's impossible in a computing class, right? Everybody's going to have their computer open and there are going to be things in the background. Just make sure that you are aware of that and that you are that you put those distractions aside when you realize that they're impacting your learning, right? Or your listening at least. Right? Labs on Tuesdays. First one is today, right after this. Attendance is required, asterisk. We'll talk about that asterisk here in a second. The readings are worth 15 points each. The labs are worth 15 points each. They're graded on completion. You are writing code and submitting code to the hand-in, grading it with the grader. If the expected output matches the expected or your output matches the expected output, you are good to go. If you're not, or if it doesn't compile, or there's a problem or a bug, go back and fix it. Resubmit it, regrade, resubmit, regrade, resubmit, regrade, as many times as you want up until the due date. The due date is midnight on Tuesdays, right? It's due the same day, but at midnight. They are designed to be done within that hour and 15 minutes. Not everybody will complete it in that hour and 15 minutes. Some of you might want to take some more time and go at your own pace. That's fine. You just have until the end of the day, midnight, right? And when I say midnight, I usually mean 1 second or 1 minute before midnight, because when you put in 12, everyone gets confused. Is it 12 noon or is it 12 midnight or what, right? So 1 minute before midnight, 11:59 p.m. When you do this, we will try make every effort to pair you up. You'll see me do it, and when we take attendance over there, whoever you sit next to, we'll say, okay, here's a great partnership. Go ahead and go to. One of you should be the driver. One of you should be the navigator. If you want to work alone, that's fine. If you want to work in a group of 3, that's fine, right? Just understand that it should be an equal effort. Collaboration, good collaboration, is not simply just watching what somebody else does and then regurgitating what they're doing. It needs to be an active collaboration of, well, I'm stuck. What do you think? Well, I think we should do this. Right? Some communication back and forth. For that reason, peer programming recommends that you use a driver and a navigator kind of a model, where the driver is actually responsible for typing and doing the code, and then the navigator is responsible for reading the handout and saying, all right, this is where we need to go next, right? Just like a navigator would. Then switch off every so often. At least switch off every week, right? You both need to hand in your own copy, but that's the kind of collaboration we want to see, right? That we want you to be helping each other out so that you're not coding in a vacuum and being lost, right? Again, it's graded on completion. Sometimes there's a worksheet. I'm trying to phase those out. Otherwise, mostly it's just code that you're completing and submitting. Hack sessions are on Thursday. Unlike labs, hacks are not designed to be completed in that hour and 15 minutes. That hour and 15 minutes is there to get you started, right? And to give you a support structure with 4 TAs, maybe myself, to answer questions just to get you started. You will have until the next Monday at midnight, again, another Cinderella deadline, to submit your code. We all know what I mean by Cinderella, right? Everything turns back into a pumpkin at midnight, right? The old fairy tale, right? So everything is due at midnight, local CDT time, right? You may work in pairs, but no other collaboration outside that pair is allowed, right? 2 is enough. 3 is a crowd, right? 4, definitely not. When you get to 3 and beyond, it's really no longer a collaboration when you're talking about beginning programming. Because now there's just too much diffusion of responsibility, and inevitably there's going to be literally a third wheel that is mooching off of it in some way, right? And we'll talk about that here in a second. If you are going to work in a pair, fine, great. Go to people in Canvas. You'll need to go to people, and I think it's actually groups and maybe hack pairs. What does it look like here? We can look really quick. Actually, no, because names will start to appear. Yeah, I'm not gonna do this because I don't want any roster names to appear on YouTube forever and ever. So go to people. You'll see groups in there, and you'll see like 50 different hack groups. You want to team up with Susan over there, right? Go ahead and team up with her and say, you join hack group 5 and I'll join hack group 5, and there's your group, right? You will be graded the same. You will be graded based on 1 submission handed in under the individual whose last name comes first alphabetically. So Apple, Fiona Apple comes before Joe Banana, right? Handed in under Fiona Apple there, right? It's due the following Monday at midnight. It's graded based on not completion, but style, documentation, design, and correctness. And each and every single individual point is accounted for in the rubric available on Canvas and available in GitHub. Right? In fact, we could take a look at that. We'll come back to you, Canvas, or Syllabus, excuse me. Documents, where's my rubric? There it is. All right. So what do we mean by good style? Appropriate variable names and function names. We'll understand this as we actually start understanding codes. But something like my variable 001 is not acceptable. My variable 002 is not acceptable, right? Good use of white space, proper indentation, making sure that everything lines up. That code is well organized and it's readable. It's not just a jumbled old mess, right? You wouldn't turn in an English paper with 1 sentence here and then five lines later another sentence, and then this paragraph is indented 10 points and that paragraph is indented 20 points, etc. Right? That would not be a readable English essay. It's not a readable program either. Documentation, well-written comments that clearly explain the non-trivial piece of code, what, the why, etc. Program design, it's well-organized and efficient. Program correctness, that it compiles and executes as expected. There is the standard rubric for every hack that you'll be submitting each week. It's worth more, 25 points, right? 2 points for style, 2 points for documentation, 5 points for design, and 16 points for correctness, right? Heavy on that correctness there, right? But these things can, you might get it wrong in the beginning, but correctness, it means that it has to compile, it has to run, and it has to run correctly, right? Okay, so altogether, that's 15 points, and 25 points. Math majors, tell me how much that is. 55 points, good. Where does the other 10 points come in for each module, for a total of 65 points for each module? It's from the attendance. We, at both lab and hack, not lecture, but at lab and hack, we will go around and collect attendance, right? We'll mark you down as attending. And if you attend and you don't, you don't come late, you don't leave early unless you're completely done, you put in a full effort, that you're not working on calc or you're not working on statics? Anybody taking statics? No, you wouldn't. Circuits? Oh, no? Okay, well, whatever you're taking, basket weaving, fine. You're not working on something else during that time. That means that you're putting on a full effort. And that means that you'll get your full 10 points. 5 points, 5 points. If you decide not to attend, or you fall asleep and you accidentally missed it or something like that, you can still earn those points back. You just have to get more than 75% of the points on the rest of the material. Those 55 points, now math majors, take out your TI-82s and tell me what 55 points times 0.75 is. That's the number of points that you need, or more, and we will automatically, whether you attended or not, we'll automatically give you those 10 points. Why? Because you've proven that you don't necessarily need to come over to lab and hack in order to get things done, right? This is putting the responsibility into your hands, right? I would recommend that at least for the first 3 weeks that you do not blow it off, right? That you attend every single one just to get into the groove of things and to understand how things work, right? If after that you decide, oh, okay, I don't need to go to every single one. I'm getting 90, 95% in the last few, right? I'm good to go, right? Then make that decision. But until then, please attend, right? So that you don't risk losing those points. Right? That's a differential attendance policy that I experimented with last semester in spring. It worked out somewhat well in that people who didn't need to attend, maybe 20%, I don't need to attend. They still got their 75%. They got way better than 75%. And so they got all their points. 60% decided, regardless of how they did on anything, they were going to get those free points. So 60% always attended no matter what. The remaining 40%, you had about half of them, 20%, that were able to do this, right, and were able to take advantage of this. The other 20% decided never to attend, never to turn anything in, and that's unfortunate, right? Don't be in that crowd. Right? Make sure that you are coming and getting those free points until you're sure that you can fly on your own. There are a couple of exams. There's 2 mini exams. The first one is is in the 5th week. We'll talk about each one of these as we approach closer. It's going to be almost exactly like a lab and hack in that you will be coding stuff. I'm not handing out pieces of paper or anything, but you will be coding programs, handing them in using the same hand-in process, the same grader process, and it doesn't work? Fine, fix your bug, hand it in again, right? These are called executable exams. And it's under the exact same conditions, just a little bit time constrained as you would face with a lab and a hack. Don't worry about them because in total, all of those points all together, that 350 points or whatever it is, it's only 30% of your grade. Right? The remaining 70% of your grade is completely under your control in that you have weeks to get things done in a lot of cases. Right? See the Canvas schedule for example. In the 5th week, that's our Fix-It exam week. I'll talk more about this Fix-It opportunity later. But there's no lab, there's no hack officially during that week. Instead, if you screw something up in the first 4 weeks, right? You miss a lab, you miss a hack, we're going to let you fix it in preparation for that first exam. That's the one and only Fix-It opportunity you get, though, right? So scared straight, right? Make sure that you're on time with everything from then on. Right? more details later on. Again, we want you to collaborate. We want you to form those good collaborations, and we want you to practice those soft skills, communicating with somebody, right? Conflict resolution. If your partner ends up not pulling their own weight, that means I've got to cut ties, right? That means that you're going to have those hard conversations with that other person, right? Collaboration is not mooching. Don't undermine your own learning experience, and don't undermine somebody else's learning experience, right? If one partner is doing all the work, you're both doing something wrong. That partner is undermining the learning experience of the person who's not doing any work because they're not learning anything. And they're undermining their own learning experience because they're letting somebody else do all the work. Don't get into that habit, right? Make sure that your collaboration is an equal effort and an equal experience level. If you had like 4 or 5 years of Java, I don't know, you programmed 50 different Roblox games or something like that. You know Lua back and forth, right? You know Python because you took 2 courses on it or something like that. Don't team up with somebody who's a complete beginner, right? Don't team up with somebody who's never had any programming in their life. Team up with somebody with a similar experience as you, right? And so that you don't risk getting into those bad collaborations. Also, branch out. Don't just collaborate with your friends, right? You might have made friends already. Maybe you don't have any friends yet. Whatever. Don't necessarily collaborate with your friends, because a bad collaboration can ruin a good friendship, and a bad friendship or what would be the other way around, right? A good friendship can ruin a collaboration as well, right? The other way around, right? Whatever it was. I should have written it down so I didn't get twisted around. All right, so any questions so far? Otherwise, let's get into the syllabus really quick. Most of it I just covered. But otherwise, dark mode, everybody okay with dark mode or not? I don't know how to change it on the fly. Anyway. 2 more quotes here from prior students. Not necessarily last semester, but the readings were the most underrated things ever. I never actually read them, but I wish I did. Thanks for providing them and leaving a whole course available to us. Enjoyed the videos. Did not really watch them until later. Realized that was a mistake now. You see a theme there? Make sure that you are utilizing the resources that we've provided. We've provided a lot of resources. We're not expecting everybody to utilize fully every single resource that we've given you. We're under no delusions. In fact, I'd be really surprised if you go in and you read every single article I post here. You watch every single video that I post here. You read all of the recommended reading rather than just the required reading, right? But find something that works for you and focus on it, right? If it's those videos, wow, those videos are great. I love those. Make sure that you are focusing on that, right? Pick something and stick with it, right? Don't fall off the deep end. No late work is accepted as well. There is an academic integrity policy. Again, outside of that, pairing collaboration, make sure that you're not sharing or copying code. We have something called MOS, Measure of Software Similarity. It is stupid easy to get to find out who copied from whom. It's just a button click on my part. It's way more sophisticated than even, like, if you've heard of Turnitin. Turnitin is plagiarism detection for, say, English papers and stuff like that. MOS is at least 20 years old. And before that, there were other tools. Because code is so structured, it is so easy to find out this code is this code, just that they changed the variable names. Or they moved this line up here or something like that. All of those superficial obfuscations to make it try to look that it's not copied code, it doesn't work, right? Not with code. So don't even put yourself into a position where you're tempted to copy something from somebody else, or to provide it to somebody else, because you're equally guilty if you do that. Lots of course resources here, Canvas, et cetera, et cetera. Let's go back to the syllabus, sorry. There is, now, this is yet to be determined, so ignore this post-requisite here. But basically, the only prerequisite for this is that you're college-ready algebra, right? If many of you are maybe taking Calc 1, okay, all right. Maybe you're taking Calc 2 or Calc 3 or differential equations already, whatever. I believe most everybody here would meet the prerequisites. You just need to know what a variable is, right? And Why is it called a variable? Variable, because its value can vary. Exactly. That's what we use in code. You have a variable, you can put 5 into that variable. Now you can put 10 into that variable, right? Now you can put 20 into that variable. That variable will vary, it will change, okay? There's a bunch of skills objectives, schedule, accommodations for students with disabilities. That's not right. Oh, you know what? I'm in the wrong syllabus. I'm sorry. I should have 195 syllabus. It's the exact same stuff so far, except for that. Documents. You have a different SSD office here. There we go. Your SSD office is located, it's called the Accessibility Accommodations. There's their phone number. There's their website. H&K, what is that? Health and what? Kinesiology. Okay, health and kinesiology. If you need accommodations for, especially for exams, make sure that you get that paperwork in now. Don't come to me with it because you don't have to violate your own privacy. You go to the accessibility office and you can come out with an accommodation plan and they inform me. Right? And then, in fact, they can even take care of it. Grading, again, we went through everything. But just to add everything up, remember there are 13 readings, 13 modules, each worth 15 points. To get you started, I'm giving everybody 20 free points. Right? Why? Just so that it adds up to 1,200 here. But also so that you end up on the right foot, right? That everybody in here has 100% in this course right now. And if you can easily maintain that, right? By just simply staying ahead of the work. Right? Shoot for that. Shoot for as close to 100% as you can, right? And you're off to a good foot right now. You've all got that 20 points. There are 12 labs, 13 modules minus 1 because of a break. 15 points each, 180 points. 13 hacks, 25 points each, 325 points. Attendance, 13 weeks times 10, 130 points. And then the exams. Again, the exams are only 30% of your grade, right? It's not like an old school college course where you only had 3 exams and they were all each worth 33% of your grade or something like that. I pulled the other classes. Does anybody still do that? Like in physics? Or, yes?
I'm in Calc 3 right now. It's going.
Calc 3? Okay. Without naming names, how old is your professor?
65, 70?
Yeah, ancient. Okay. So this stuff is on the way out, right? That kind of emphasis on what's called summative assessment is on the way out, right? And it's a good thing, right? Anyway, the details for each one of those is throughout the syllabus. There's the standard scale. I do give UNO does have pluses, if I remember, pluses minus system, and usually I haven't had to scale things. But if there's necessary, I only scale at the end. I don't scale any individual stuff. Right? Late work policy, no late work. Web grader policy, it's got to work or it ain't gradable. Right? Academic integrity policy. Right? Communications and getting help. The best way to get help is Piazza. Right? And hopefully you've accepted the invite to this. Hopefully there's nothing that's sensitive here. I don't think that there is. But right now you can see that we have a live Q&A going. Nobody's posted any questions. Right? If you prefer, you can also go ahead and post to the YouTube live stream chat. Somebody did. Hello. Good day. I don't know. I have no idea who they are. It's usually just random people that find the streams for some reason. But if you are in this class, go ahead and send a shout out. Right? But in any case, this is the best place to get an answer. I probably will not have office hours dedicated unless it's by appointment, and even then only via Zoom, because I'm on the UNL campus Monday, Wednesday, Friday. I'm here Tuesdays, Thursdays, but I am booked solid almost every single day. Right? That's what happens when you've got 4 courses. Right? Let's see, what else? Otherwise, that's the place to answer. Because in lieu of holding office hours, I answer everything on this. You'll find that statistically in previous semesters, I think that the average response time is only 5 minutes. Now, if you're posting at 1 a.m., it's going to be longer than that. All right? Like I said, average response time. All right, and then of course the TAs will be on Piazza as well. Okay. All right. And then the great thing about that is that you can post anonymously. You can post privately so that nobody sees it except for the instructors. You can answer anonymously. You can appear anonymous to all your classmates for fear of, this is a stupid question. No, it's not a stupid question, because if you're asking it 9 times out of 10, there's at least one other person that doesn't know either, right? So we use this forum so that when we answer a question, everybody gets the benefit of the answer, right? So 9 times out of 10, you'll find that the same question that you had is already up there, and somebody's asked it, and somebody's already answered it. You can also answer other students' questions as well, right? All right. That's the syllabus. Let's see, what else? How to succeed in this course? Don't assume anything about yourself or about the course, right? There have been plenty of stories. Well, this other professor did things this way. Well, that's that 65-year-old professor given 3 exams, each worth 33 points, right? That's a different course. That's a different person, right? Don't assume anything about yourself, right? Again, if you're that person that's had 50 Roblox games and you made money or made fake money out of it somehow, right? Because it was so popular, right? Don't assume that those skills will necessarily translate over to C, right? If you've had 4 years of Java, who knows? Maybe you had 4 years of bad habits Java, right? And it's going to take some work to get out of those bad habits, right? We start with 0 knowledge, right? Even if you have greater than 0 knowledge, you will still learn something. If you already knew C, you would not be taking this course, right? Very, very few people have the opportunity to learn C K through 12. I've never heard of a K through 12 course that's offered C. We offer it through the Nebraska Now program, but I don't think anybody has ever taken it. Don't ask me why, right? It's only $300, right? Anyway, coding is a skill that needs practice. You would not expect to pick up the violin and even sound halfway decent on your first try, right? That's because in a lot of cases, you need fundamentals. You need years of practice. And that's with any skill, right? Even if you have a natural talent, you still need that practice to make sure that, that you're honing that talent and that you're not losing that talent over time. Always compare yourself to yourself and never to others. If you started with 0 knowledge and it takes you 2 hours to do that first hack instead of that person that took 4 years of Java and they were able to do it in 15 minutes or something, right? Exaggerating, of course, it's not going to be that way. But don't compare yourself to that person. That person's had 4 more years of experience than you. Compare yourself to yourself at the beginning of the semester, at the end of the semester, how you grew and what skill levels you built up over that time. And then don't even wait till the end of the semester. Look at yourself in the first week, and then by the 5th week for the first exam, look back and say, wow, that first lab or that first hack that I did, it took me like 2 hours to do that, 3 hours to do that. I could do that now in only 30 minutes or something, right? From a fresh start. Right? Everybody probably will at some point struggle, right? That doesn't matter because everybody can succeed if you take advantage of all of the resources that we've provided. Right? All right. With our remaining time here, we can head over and get started on the lab, or I can give you a really quick introduction to what it's going to look like for those of you that might be coming at, what's the second one, 3:30? 3 o'clock? Okay. Visual Studio is, of course, a Microsoft product. Code Spaces is, I believe, it might be a Microsoft product, I don't know. But in any case, we are mooching off of Harvard here. They've provided these free. I asked them if we could use it 4 years ago, and they said yes, and I've never asked them since, can we continue using it? And we've never run into a problem yet, so we're going to continue to use their stuff, right? If you did, you can buy Code Spaces. I think it's like, might be free for students. Otherwise, it's a pretty penny, right? But this is free, and you don't have to use anything. You do need a GitHub account, so you do need to sign up with GitHub. Let me reset this. Right? That's what it looks like once you've logged in. What does it not look like? What does it look like before you've logged in, before you've registered, something like that? Sign up with GitHub now. Otherwise, if you've already got a GitHub account, just sign in. And once you've got a GitHub account, you can get free, easy access to this IDE. I've already set my stuff up here. That's because I did it a while ago, and this is what not exactly what it'll look like when you're done with your first lab today, but it'll look something like this. You'll have a computer science 1 folder. You'll have folders for your labs and your hacks and your miscellaneous whatever. I'm going to go ahead and go into miscellaneous here. CD stands for change directory, right? I'm going to go ahead and remove that hello because I just did that somewhere else. Now you can remove files over here in the File Explorer. Right click. And then, where is it? Delete. Delete permanently. Yes, I do want to delete that, right? Sometimes it gets stuck. I already deleted that hello.c file, right? And I said, yes, I wanted to rm it, remove it. Sometimes it just needs to be refreshed over here. This little refresh button. And now you see that it's gone. Let's go ahead and recreate that file that I was just using, hello.c, right? All right. So this is just a plain text file. It's not a Word file. It's not a word processor. It's plain text. The code that you start entering and typing into this, that's going to be your program. Obviously, that's not programming, right? There is a programming language called, well, I'll just shorten it to BF. You can look it up on your own. But it's kind of a nonsense joke language. I mean, it is a programming language, but it's intentionally made to be a terrible language, right? Where I think that there are only 3 symbols or something like that you use, some crazy stuff like that. What I'm going to do is I'm going to start my program with a header comment, right? All of your programs, at least initially, are going to begin with a comment that says what this program is. If you were writing it in English paper, what would you put at the top? Your name, so that it can be graded, okay. Author, there we go. What else would you put on there? Oh, an email, so there we go. Don't use that email anymore. There we go. All right, what else? Date, right, 2022. It is August, and it is the 23rd. That is the only correct way to write dates, right? Europeans are wrong. Americans are wrong. Computer scientists are right. Why? Year, month, day.
Sorts alphabetically?
Exactly. Alphabetically or lexicographically. That all dates now are automatically sorted, right? And sortable along with all those numbers, right? As long as you prepend everything with a 0. Okay? So there's my date. And we're going to give a purpose to this. A basic hello world program. Right, there we go. If it was a more complex program, I'd have more complex explanation for what this program does. Is this big enough for the folks in the back? All right. Otherwise, I can't increase the font. Right. It's just not going to look as good. Right. Now, we don't start from scratch. We need some libraries. We need the standard library. stdlib stands for standard library. And we need to include, because we're going to be doing some input and output, stdio. IO stands for input, output, right? And we need to include those libraries so we don't have to reinvent the wheel. We don't have to reinvent all of the basic variables. It's part of the language anyway. We don't have to reinvent the print statements that we're going to be using here in a moment, right? Every program needs a starting point. argc, excuse me, argv. Don't worry about that magic stuff within the parentheses yet. We'll get to it later, right? But the takeaway here is that every program has a starting point, right? You've got to start a program somewhere. And for C, that's going to be the main function, right? If you do not have a main function, you do not have an executable program, right? So this is where we'll start. Again, don't worry about that for now, right? That's the end of the program. We're going to return 0. We're done, right? All I'm going to do here is print a message. Printf is short for print formatted. Right? Double quotes here is a string, and anything that I put inside of this will be printed. So I don't want garbage. I want hello world. Right? I'll leave it like that for now. When you're writing your English paper, after you put the header at the top and you start writing stuff, you have paragraphs. You have blocks of code. You have sentences. You have lines of code. What belongs at the end of every sentence in an English paper? A period, or an exclamation point, or question mark, whatever. Code is the same way, at least C-style syntax is. What is at the end of every executable statement? A semicolon. That says that's the end of the line, right? This is a sentence. This is an executable statement. That's the end of it. Right? Once we've got this, of course, I can't do anything with it. In fact, I don't even have my file utility anymore, I don't think. Right? Nope. It doesn't know what this is. So if I try to run this, right? Run the hello.c file, please. Right? That's not a command that it's going to understand. Again, we're not at Star Trek AI where I just tell a computer exactly what I want it to do in plain old English. Right? What I need to do is I need to take this code, which a computer does not understand, and I need to translate it. I need to compile it into machine code that a computer does understand. GCC is going to be our compiler of choice. GCC used to be known as GNU's C compiler. I believe now it's just known as GNU compiler because you can actually compile many different programming languages using GCC. But I'll go ahead and compile this as hello.c. Right? No news is good news in the Unix world. If everything went right, it just goes back to the command line and sits there and waits for you to enter the next command. If something bad happened, for example, I forgot that quote, right? A beginning quote, double quote, end double quote. If you only have one, how does it know where to end? When something goes wrong, it will tell you, right? And sometimes it's even helpful. Missing terminating double quote character that started at line 14 at this character, and yeah, you missed it. Where should it end? Right? Does it end here? Does it end here? Does it end here? Right? You need to go back and you need to fix it. Right? Once you fixed it and you recompile it, oh hey, I didn't have to type gcc space hello.c, did I? What did I do? Exclamation G. Exclamation and then a character executes the last command that began with that character that you ran. Right? You can also just hit up and scroll through all previous commands that you've ever done. Right? You can hit down to scroll through all the commands going forward. Right? You can use completion. I don't like typing. I don't want to type hello. H-E. Do it for me, please. Right? That was a tab. That's tab completion. H-E, tab over, and it completes it for you. Right? Just these little tricks, and as you'll pick up throughout the semester, and frankly a lifetime of tricks like this, will make sure that you are super, super productive in the future. Right? Every little trick that you see like that in your life, you'll say, I wish I knew about that 20 years ago, right? That would have, over the last 20 years, that would have saved me 1 second a day. 1 second a day for 20 years. I could have gone to a movie or something, whatever. Right? So now let's run it. Actually, before I do that, let me type ls. ls is short for list. It lists all the files in the current directory. A directory is nothing more than a folder. Think folders. These are the folders over here. You have the same folders down here. I am in the CS1 miscellaneous folder. CS1 miscellaneous folder. There's my hello. But I don't see that a.out file. Again, sometimes it needs to be kicked in the butt. Refreshed, and there it is. Right? There's nothing I can do with that file. In fact, it probably won't even let me open it since it's a binary file. Right? File is not displayable in the internet as either binary or unsupported text format. Okay, open it anyway. Oh, hey, awesome. Come on. Anyway, I'll show you what it looks like. More a.out. All right, fine. Hex dump a.out. There we go. That's what it looks like. What is it? Bunch of zeros and ones, right? The zeros and ones that are being displayed as hexadecimal. That's base 16. So 0 through 9, because we're humans, 10, we're base 10, right? A computer is base 2, 0 or 1. You can also have other base systems. Hexadecimal would be 0 through 9, and then A, B, C, D, E, F, right? It's just a different way of counting. They're all equivalent, right? Again, not all high school students are going to be well versed in the binary arithmetic that Isaac Asimov said that we would be, right? Instead, we have tools like hexdump that tells us what it looks like binary-wise, right? That is actually something that is executable, right? So let me list it again. A.out. You see that it's in green. You might have to strain really hard to see that it's in green. But I can actually run that now. Oops. A.out. There we go. So what did I type there? dot, and then that's a slash. Is that a, what kind of slash is that? There's a forward slash and a backslash. Which one is that? Forward. Why? Because I look right, we read left to right, and am I leaning forward or am I leaning back? Right? That's how you can remember which one is which. Dot slash a dot out. And it runs. You saw it print hello world, right? But not really nicely. Then it went back to the command line, and it's now waiting for my next command here, right? But it didn't break between the exclamation point and this prompt right here. Let me go ahead and fix that. Here's our first special character. Now, is that a backslash or forward slash? Backslash n. That means go to the next line. If I had just hit enter and went to the next line, that's me in the text editor going to the next line, right? That's not the computer, the program that I just wrote, going to the next line. Instead, we need an explicit thing like this, right? This is actually on the, it's on the QWERTY keyboard, right? It is enter, all right? It goes back to the day of drum typewriters, right? You can go down to the next line and then all the way back at the beginning, right? Or you can just go down to the next line. This is the difference between an end line and a carriage return. Has anybody actually ever typed on a old typewriter? Right, tick, 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 ding. What needs to happen now? You've seen it in movies at least, right? You need to push it back, right? That's what the slash n is, the backslash n is. The slash r here is just that ding. It goes. You can go down to the next line, right? When I compile it like this, and I run it, I'm not sure what will happen. Yeah, it doesn't even, it doesn't even print it, right? Why? What happened? It went down to the next line and then printed the slash workspace CS1 miscellaneous, overwriting everything that I probably just typed, that I just printed, right? So it's like on a typewriter, if you type, then push it back on the same line and type, you've got a T over an H or something, right? You're typing in the same place over and over and over again. Again, this all goes back to old school typewriters. Why? Because that's when computers started, the typewriters predate, in fact, the QWERTY keyboard predates modern computers by what, 100 years or something? Right? They had typewriters way before computers. Anyway, slash n, let me go ahead and recompile that and see hello world. Right? If I make a change, I'm really excited to say hello to you, right? I made a change to the code, but did I make a change to the compiled program? Did I recompile it? Nope. So it's not going to change its behavior, right? I need to recompile it. And actually, any change that I make, I need to recompile it after I've made that change and then run it again. And I will see those changes reflected, right? Some IDEs have, like, say, a play button. And this play button is for run and debugging. We won't get into that. We'll get into a different tool called GDB. But some IDEs have this nice play button, this pause button, and this stop button, right? They don't have, that's not here in visual code, right? Instead, you're working at the command line. Working from the command line is a little bit more upfront investment on your understanding. But again, it pays off eventually. Somebody who works from the command line, they've done studies before, but like a sys administrator, and when they work from the command line, they are at least 10 times as more efficient and 10 times more productive than some sysadmin that has to point and click through a bunch of tools, right? The Unix philosophy is build small stuff so that you can combine it later on and get a lot of stuff done. For example, I could say sort hello, or actually sort hello.c. Right, there we go. I sorted all the lines, right? How many characters are in there? Word count, number of characters in hello.c. There were 228 characters. Word count lines for the hello.c. Right? There are 16 lines in hello.c. Right? Now this is a small program and I can see it all on one screen. But if it were a large program with 1,000 lines of code, maybe I would want to find that line of code with the hello in it. Hello. Oops. Other way around. Actually, world. Hello. There. It actually appears twice on that line and on that line. Right? And then you can what's called pipe these things together. All right, so how many characters are there on the lines that contain world? 69 characters. Right? That was just a coincidence. Right? Ha ha. Beavis and Butthead is coming back, so I guess it's on a paid channel that nobody can get to unless they pay for it, right? But there, the number of lines, right? 2, right? So how many lines does the word or the word world appear on in my program? 2, right? And I was able to do that by piping these two things together, right? This is what is that called? That vertical line. Oh, it's called vertical line. Does anybody else have any other names for it? It's absolute. It's used in the absolute value in math, right? It goes by many names. In math, it's also called Sheffer strokes, and it's also used in or, right? Do you have a name for it? No. Okay. And otherwise in Unix, it's called piping, so we call it a pipe. It's just a vertical pipe, right? It's a pipe at the top of the ceiling that goes down to the floor. Right? All right. Any questions about any of this? Otherwise, I'll give you a little bit extra time to head on over to PKI 311 for your first lab. For those of you in the 130 section, not everybody will fit in PKI 311. I don't remember what the overflow room is, but be patient and we'll direct you.